all my dear student friends. Welcome to this session. We are studying the subject power engineering and refrigeration. Right now we will be discussing about the gas turbines. So let us introduce ourselves to the gas turbines. Gas turbines are nothing but the prime movers like the IC engines. The difference between the gas turbines and the engines is that gas turbine is a rotary type of prime mover, whereas the engine is a reciprocating type of prime mover. Ultimately, the reciprocating motion is converted into rotary motion. But in IC engine, the beginning is with the reciprocating motion. But in gas turbines, we begin with the rotary motion and there is no reciprocating motion. So we call gas turbines as the rotary type of prime movers. So gas turbine is the power producing device or a prime mover like an engine. But there is one more difference between the engine and the gas turbine. In the engine, the several operations like compression, combustion and expansion take place in a single vessel, that is the cylinder. But in case of gas turbine, compressor takes place in a different device known as the compressor. Then we have a separate combustion chamber for the combustion of the fuel, and the expansion takes place in the gas turbine, which is also separate. So the different operations like the compression, expansion or the combustion take place in different vessels in case of gas turbine, whereas in case of IC engine all these operations are taking place in a single vessel, that is the cylinder of the engine. So gas turbine is a rotary type of thermal prime mover used for the production of mechanical power. Gas turbines are having outstanding advantages like exceptional reliability. So gas turbine is quite reliable. We can depend on the power which is developed by the gas turbine. It will never fail. The vibrations in case of gas turbines are less because directly the motion obtained is the rotary motion. There is no reciprocating motion, and therefore the size of the flywheel is also small and the flywheel is having less weight because there is less fluctuation in the speed, almost no fluctuation in the speed and the torque which is produced in case of the gas turbines. And the important advantage of the gas turbine is that low grade fuel can also be used. So these are the advantages of the gas turbine over the IC engines. And we already compared the IC engines with the gas turbine. In IC engine, compression, combustion and expansion take place in a single cylinder, while in gas turbine, compression, combustion and expansion take place in separate components. Let us try to see the applications of the gas turbine. For the generation of the electricity, whatever mechanical work is obtained with the help of the gas turbines, can be utilized to run the generator, and thus electricity can be generated. And this is used as standby in hydroelectric power plant. So whenever there is some maintenance work going on in the hydroelectric power plant or some other issue in the hydroelectric power plant, so that time we can use the gas turbines as the standby device for producing the power, for generating the electricity. Gas turbines are also used in industries for crude oil pumping and the refining process. Supercharging of IC engines is also done with the help of the turbines. In automobiles also we have several applications of the gas turbines. For locomotive propulsion, gas turbines are used, and for marine ship propulsion also we use the gas turbines. In aircraft also gas turbines find its important applications. So these are the applications of the gas turbines. Let us study the classification of the gas turbines. There are several ways of classification. First of all, according to the condition of combustion. Constant pressure combustion gas turbine. So when the combustion takes place at constant pressure in a gas turbine, in the combustion chamber of the gas turbine, then it is called as the constant pressure combustion gas turbine, or it is also called as the continuous combustion gas turbine. Since the combustion takes place continuously, so there is no abrupt increase in the pressure. So the pressure is almost constant in this type of gas turbine. Another type is the constant volume combustion gas turbine or explosive combustion gas turbine. In case of the constant volume combustion gas turbine or the explosive combustion gas turbine, the combustion doesn't take place continuously, but there is a explosion. All of a sudden a large quantity of heat will be produced and a large quantity of fuel will be burned. So there is an explosion. So there is a sudden rise in the pressure, right? So it is a volume is constant, but the pressure is not constant. Pressure will rise in this type of turbines because the combustion takes place in the constant volume, and it is an explosive type of combustion. According to the thermodynamic cycle, the gas turbines are classified as Breton or Joule cycle. So this Breton or Joule cycle is used for constant volume gas turbine, and Atkinson cycle is used for the constant pressure gas turbine. Ericsson cycle is used for constant pressure gas turbine, and Atkinson cycle and Breton or Joule cycle, they are used for the constant volume gas turbine. According to the cycle of operation, gas turbine may be open cycle gas turbine. So this is used for constant volume or constant pressure gas turbine. This open cycle gas turbine may be either constant volume or it may also be constant pressure gas turbine. Now the closed cycle gas turbine is used for the constant pressure gas turbine. So the closed cycle gas turbine is only constant pressure gas turbine. And we are also having the semi-closed cycle gas turbine. According to the arrangement of the shafts, the gas turbine maybe single shaft gas turbine. Here the compressor is run by power turbine. We are having the multi-shaft gas turbine. So separate turbine is used to run the compressor in addition to the power turbine. So in case of the multi-shaft gas turbine, you will find that there is one more turbine, a small turbine, which will just drive the compressor, and that will not produce the power for the use output purpose. So the power of this small turbine is not utilized by the application. It is not used as the output, but that is only used to run the compressor. But the main turbine will give the output power. So this type of gas turbine is the multi-shaft gas turbine. And in case of the single shaft gas turbine, there is only one turbine, power turbine, and the same turbine will run the compressor. So part of the power which is produced by this turbine will be used to run the compressor or drive the compressor. Gas turbines are also classified according to the fuel used. Liquid fuel gas turbine, solid fuel gas turbine, or the gaseous fuel gas turbine. According to the application, the gas turbines are classified as stationary gas turbine, automotive gas turbine, locomotive gas turbine, marine gas turbine, and aircraft gas turbine. So this classification is based on the application of the gas turbine, whether it is used in the automobiles or in the locomotives, whether in the ships or in the aircrafts. So this was about the classification of the gas turbines. Thank you, my dear friends.